Hello everyone. Thank you so much for viewing this video. Before we get started with discussing the contents of the video, I wanted to introduce my nonprofit, the Accelerated Training Program. Our vision is twofold. First, we want to expose all marginalized groups to cybersecurity education, as well as removing the systemic exclusion of cybersecurity education to marginalized groups. Our website is www.t-atp.org. And if you would like to partner or want to learn more, please visit our contact page where you can fill out your name, your email, and a message, and we will get back to you. And again, thank you so much for viewing the contents of this video. Please check out the nonprofit when you have a moment, and let's get to the video. Hello, everyone, and welcome to day 11 of Try Hack Me's Advent of Cyber. We're in a new section, Memory Forensics. Not all gifts are nice. Okay. So, the story. Okay. The elves in Santa's Security Operations Center are hard at work checking their monitoring dashboards when Elf McDave, one of the workshop employees, knocks on the door. The elf says, "I've just clicked on something and now my workstation is behaving in all kinds of weird ways. Can y'all take a look?" Elf McSkitty tasks you, Elf McBlue, to investigate the workstation. Running down to the workshop floor, you see a command prompt running some code. Oh no, this is not what we want, especially at the Security Operations Center for Santa. This is not good, you don't say. You immediately create a memory dump of the workstation and place this dump onto your employee issued USB, returning to the Santa's Security Operations Center for further analysis. You plug the US you plug the USB into your workstation and begin your investigation. So, what is memory forensics? Memory forensics is the analysis of the volatile memory that is in use when a computer is powered on. Computers use dedicated storage devices called random access memory, or RAM, to remember what is being performed on the computer at the time. RAM is extremely quick and is the preferred method of storing and accessing data. However, it is limited compared to storage devices such as hard drives. This type of data is volatile because it will be deleted when the computer is powered off. RAM stores data such as your clipboard or unsaved files. We can analyze a computer's memory to see what application, processes, what network connections were being made, and many more useful pieces of information. For example, we can analyze the memory of a computer infected with malware to see what the malware was doing at the time. Let's think about cooking. You normally store all your food in the fridge. A hard drive is this fridge. When you are cooking, you will store ingredients on the kitchen counter so that you could quickly access them. But the kitchen counter RAM is much smaller than a fridge hard drive. Okay, why is memory forensics useful? Memory forensics is an extremely important element when investigating a computer. A memory dump is full capture of what was happening on the computer at the time. For example, network connections or things running in the background. Most of the time, malicious code attempts to hide from the user. However, it cannot hide from memory. We can use this capture of the memory for analysis at a later date, especially as the memory on the computer will eventually be lost, if, for example, we power off the computer. By analyzing the memory, we can discover exactly what the malware was doing, who it was contacting, and so forth. So, an intro to processes. At the simplest form, a process is a running program. So, for example, a process is created when running an instance of Notepad. You can have multiple processes for an application. For example, running 3 instances of Notepad will create 3 different processes. This is important to know because being able to determine what processes we're running on the computer will tell us what applications we're running at the time of capture. So on Windows, we can see processes using the task manager, and that is pictured here. Now, there are two different types of processes. So we explained one of them up above. So that's the user process, and that's a process that the user or us, what we've launched. For example, text editors, web browsers, etc. So Notepad, this is a text editor that is launched by the user, and that was the example that was used above. Background processes, these are processes that are automatically launched and managed by the operating system and are essential for the operating system to behave correctly. So DWM.exe, which is an executable, this is essential for Windows, and this is responsible for displaying Windows and applications on the computer. So going back to this task manager, we see that there are four applications running: Windows Explorer, Task Manager, Notepad, and we see a secret file.txt in Microsoft Edge. And then we see so these are um, processes that we, the user, initiated. So Windows Explorer, that's where you can look at files on the system. Task Manager, that's the screen here. Notepad, we have a file open, secret file.txt. I wonder if that's important. And a web browser. And we have the background processes that is needed for the operating system, such as Windows Shell Experience Host, VM tools, core services. So more often than not, you will not mess with the background processes because these are needed for the operating system to run. And terminating one of these processes is essentially making your operating system either very slow or inoperable, meaning it will stop working. So we will not mess with these processes at the bottom, the background processes. It seems like this is where we want to be. Just a hunch. Okay, so introducing Votility. So this is an open source memory forensics tool written in Python, which is a programming language. So Votility allows us to analyze memory dumps taken from Windows, Linux, and Mac devices and is an extremely popular tool in memory forensics. For example, Votility allows us to list all processes that were running on the device at the time of capture, list active and closed network connections, use YARA files to search for indicators of malware, retrieve hash passwords, clip contents and contents of the command prompt, and much more. Okay, so once volatility and its requirements, Python, are installed, Votility can be run using Python 3 vol.py. And all Python scripts have the extension .py. The terminal below displays Votility's help menu, and we see it lists what we can do. Okay, today's task will cover Votility 3, which was initially released in 2020 to replace the deprecated Votility 2 framework. Votility requires a few arguments to run. So first, we call the tool using Python 3 votility.py. Next, we provide any options such as the name and location of the memory dump. Third, the action we want to perform. So what plugins we want to see, we'll come to this shortly. Okay, so some commands we can use. Some command options, -F. So this argument is where we provide the name and location of the memory dump. So for instance, Python 3 votility.py, this -F, and this is the path to our memory dump. -V, the argument increases the verbosity of Votility. This is sometimes useful to understand what Votility is doing in case of debugging. Just know this will be very noisy, so whatever Votility finds is going to dump to the screen. -P, this argument allows you to override the default location of where plugins are stored. So if you have custom plugins, you will specify the path to your custom plugins. -O, this argument allows you to specify where extracted processes or DLLs are stored. So if we want to see where the processes or DLL, dynamically linked libraries that are used in Windows, you use the -O to find that path and specify that path. Okay, finally, now we need to decide what we want to analyze the image for. So Fertility uses plugins to perform analysis such as listing processes, listing network connections, listing contents of the clipboard, notepad, or command prompts, and much more. And if we're interested, we could click here for the documentation. Reading the documentation is always good, especially when working with a new tool we never used before. So the task for this day is we're going to see what operating system the memory dump is from, see what processes were running at the time of capture, see what connections were being made at the time of capture. So we're going to use Fertility to analyze an image. Before proceeding with our analysis, we need to confirm the operating system of the device that the memory has been captured from. We need to confirm this because it will determine what plugins we could use in our investigation. First, let's use Image Info plugin, the Image Info plugin, to analyze our memory dump file to determine the operating system. So how we would do that is Python 3 vol.py-f. So this will let us know where our dump is. Excuse me, not our dump, but our image file. And then we're going to use the windows.info and then we're going to say windows.info, but it would seem like we would want to use image info because they've already skipped a step and let us know it's Windows. Okay, it's kind of weird. Okay, so from here we can see that it is indeed Windows. Okay. With this information, we now know we need to use the Windows subset of plugins with Fertility. The plugins that are going to be used in today's task are detailed in the table below. So Windows PS list. So this is going to list all the processes that were running at the time of the capture. Windows PSS scan. This allows us to analyze a specific process further. So this is to discover what a specific process was actually doing. Windows.dump files. This allows us to export the process where we can perform further analysis, static or dynamic analysis. To export a specific binary that allows us to further analyze it through static or dynamic analysis. So static analysis is where you're looking at, for instance, we're looking at this process. We're seeing what it does, but we're not making changes to it. Dynamic analysis is where we're actually interacting with the process. So, for instance, if the process needs parameters to run, to execute, we're providing those parameters. So, as the word states, it's dynamic. So, we're actually interacting in this case with the process and seeing what will happen and how it runs, how it executes. Windows.netstat. So this plugin lists all network connections at the time of the capture. So this we want to see what network connections were made, such for instance, was it connected to a malicious server? Can we get the IP address to implement defensive measures on other devices? Do we know if an IP is malicious and another device was communicating with it? Things of that nature. So this isn't all of the plugins for Windows. So we can actually go here to get all of them. So here is an example of how to use it. Okay, so let's start the machine. Okay, so Fertility and our memory file in this case is called workstation.vmem for virtual memory or memory something memory. It's located at home Elf McBlue Fertility 3. So let's go there. Home Mc. Okay. Where am I? Okay, so I'm already here. So I did PWD, that's print working directory, in Linux, and Unix. So now I'm changing directory because I want to go to Vitality 3. And what you can do is you can type the first couple of words, excuse me, the first couple of characters, hit the tab, and it will autocomplete. And we did that. Now, it will autocomplete if there are no other words that start with VOL. So, for instance, if we had three files that were VOL, it would list all three files and then you would pick the one that you wanted. Okay, so we're going to say ls because we're going to list. So I'm going to say python 3 vol.py, and I want to say -f workstation.vmem. Oh, and we need plugin. So let's do windows.info. So we're going to need to know what version of Windows we're running. Okay, oh, this might take up to 10 minutes. Let's hope not. Okay. So we see a major and minor. So I wonder if I need. Can I? Oh, darn, this doesn't have the internet. So let me go here. Okay, so this is Windows 10. Okay. And that was figured out by the major operating system version. So that's why I saw that 10.0. And so I just looked here, major operating system version, went to Google, Windows Major version 10, Windows 10. Okay. Excuse me. Okay. What is the name of the binary gift that Santa left behind? So let's look at another, and let's say let's do the Windows because we need to see what processes was on this machine. Okay. And what are we trying to do again? Okay. Okay, so we're looking for what Santa left behind. Some of these I see are definitely related to Windows. I'm looking. Mystery gift.exe. Mystery gift.exe. Okay. What is the process ID of this binary? I want to say 5888. 5888. Okay, so it's the one before it, so 2040. Okay, so it's this number here. It's the first number. Dump the contents of the binary. How many files are dumped? So we want to dump. So we're going to say windows.dump files PID 2040. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so if we want to learn more about fertility, please check out the room here. And again, if we want to learn more about forensics, there's a digital forensics and incidents response module here. So that's if we want to learn more. That was fun. I have not. This was my first time using Fertility. I have heard of it, but really never used it. And I'm interested in playing with it a little more. So I actually might do the Fertility room after Advent of Cyber. So I hope you learned something in this video because I did. Again, I never played with memory or done memory forensics. So this was fun. And I can't wait to see you in the next day's lab. And I wonder what shenanigans is going to happen leading up to Christmas. Have a good day. Bye.